Welcome to online class, Department of Collegiate and Technical Education, Automobile Engineering Department, 5th semester. Name of the subject is Design of Machine Elements. And now we are in Unit 4, that is Design of Simple Machine Parts. So today we have to study session number 13, that is solved example on quarter joint. Before starting this session, let me introduce myself. My name is Vinayak S. Nayak, Selection Grade Lecturer, Tipu Shahid Polytechnic, Hubli. Dear students, in the previous session, we have studied design of quarter joint, application of quarter joint, design procedure of quarter joint, and we have solved some examples. So today in session number 13, we will solve one more example on the quarter joint. So here today's content are: number 1, solving example on design of quarter joint. Second one, as usual, multiple choice questions. And third is references. So, dear students, we will study one more problem and we will solve this problem, which is on the design of quarter joint. The problem is: two mild steel rods 40 mm diameter are to be connected by a quarter joint. The thickness of the quarter is 12 mm. Calculate the dimensions of the joint. If the maximum permissible stresses are 46 megapascal in tension, 35 megapascal in shear, and 70 megapascal in crushing. So, by reading the problem carefully, now we will write the given data. So, he has given the diameter of the rod, that is small d is equal to 40 mm. Then thickness of the quarter is small t is equal to 12 mm. Then tensile stress, that is sigma t, is equal to 46 megapascal, that is equal to 46 Newton per mm square. Then shear stress, that is tau, is equal to 35 megapascal, that is equal to 35 Newton per mm square. And crushing stress, that is sigma c, is equal to 70 megapascal, that is equal to 70 Newton per mm square. So in this problem, the rod diameter and thickness are given. So we have to first find the load, capital P, carried by the rods. Dear students, already you have familiar. So we have 12 steps for designing the quarter joint. So one by one we will solve. We know that the tearing resistance of solid rod, small d, is equal to, with respect to the tearing resistance, capital P, is equal to pi by 4 into d square into sigma t. So which is in the page number 65, and the equation is 4.16a in the design data handbook written by K. Mahadevan and K. Balveera Reddy, which is prescribed by our board. After substituting the values of small d and sigma t, the value comes of P is equal to 57,805.3 Newton. So that is the load carried by the rod. Similarly, diameter of spigot, small d1. So we have to use the equation 4.16c, which is on page number 65, and again After substituting the values, we are getting the value of small d1 is equal to 49 mm. So here, dear students, to calculate the value of d1, we have to use the quadratic equation. Then approximately 48 mm is the value of d1, and the after substituting the value, that is the thickness, t is equal to 0.25 d1, because here the value of thickness is given, that is 12 mm. So after calculating, the value of d1 becomes 48 mm. Dear students, after calculating the values of d1 and t, we have to check for the induced crushing stress. So when we substituting the values of p, d1 and t, the sigma c becomes 98.3 Newton per mm square by using the equation 4.16b. But since the value of sigma c is more than the given value, because the given value is 70 Newton per mm square, so hence the values of d1 and t are not safe. So therefore we have to calculate the new values of d1 and t. So after substituting the values of p, small t and sigma c in the equation 4.16b, the values of d1 comes 58 mm, and the value of thickness, that is small t, comes 14.5 mm. So these are the safe values. Next, diameter of spigot collar d2. So for this we have to use the equation 4.16d, which is on page number 65 in the data book. So the value of d2 comes 67 mm. Similarly, the fourth step, thickness of spigot collar t1. For this we have to use the equation 4.16e, again on the page number 65. When we substituting the values of capital P, d1 and tau, the value of t1 comes 10 mm. Fifth step, distance from the end of slot to end of rod, that is L1, can be calculated by using the equation 4.16g, again on the page number 65. So the value of L1 becomes 15 mm. Similarly, the sixth step is outside diameter of socket d1. So for this we have to use equation 4.17a, which is on page number 67. So after putting or substituting the values and by using the quadratic equation, the value of d1 comes 73 mm. Seventh step, diameter of socket collar, that is capital D. For this we have to use the equation 4.17b, again on the page number 67. So we get the value of capital D is equal to 115 mm. Then eighth step, thickness of socket collar, that is a small l. For this we have to use the equation 4.17c, page number 67, which is in the design data handbook written by K. Mahadevan and K. Balveer Reddy. After substituting the values, the value of small l comes 15 mm. Then a ninth step, width of quarter small b. So to calculate this, we have to use the equation 4.18a, again on the page number 67, that is capital P is equal to 2 into b into t into tau. So dear students, why we should use this equation only? So we have to calculate the width of quarter, that is small b. So the small b is in the this equation only. So that's why we have to use this equation, that is p is equal to 2 into b into t into tau to calculate the value of a small b. So that comes 57 mm. Dear students, 10th step is length of quarter, that is 4d. So already we know the length of quarter is 4 into d. So the value of d is here 40. So the length of quarter L is equal to 160 mm. Similarly, as usual, the taper in quarter is 1 in 24 and the clearance of quarter is 2 to 3 mm. So, dear students, now we shall solve some of the multiple choice questions. Again, you are familiar. So each question is having 4 answers. So in that, one will be the correct answer. So we have to choose the correct answer. Question number 1. Newton per mm square or megapascal is the unit of, the options are tensile stress, B is shear stress, C is crushing stress, and D is all of these. Since the options A, B and C are the stresses, which are the units are having Newton per mm square or megapascal. So here the correct answer is D. It is all of these. So second one, the diameter of the rod small d in the equation P is equal to pi by 4 d square into sigma t, when sigma t is equal to 46 megapascal, small d is the 40 mm, then the value of P is. So when we substituting the values of sigma t and the value of d in the equation, so we are getting the value of capital P is equal to 57,805.3 Newton, which is in the option A. So A is the correct answer. Third one, the taper in quarter should not exceed. The options are A is 5 in 25, B is 1 in 24, C is 10 in 30, and D is all of these. So already we are familiar, the taper in quarter is should not exceed 1 in 24. So here the correct answer is the option B, that is 1 in 24. Fourth one, when diameter of rod D is 40 mm, then the length of quarter L is. The options are 140 mm, B is 120 mm, C is 160 mm, and D is 180 mm. So the length of the quarter is 4 into diameter of the rod. So 4 into 40 means 160 mm. So that's why here the correct answer is C. The option is C option is the correct answer. Fifth one. Distance from the end of the rod L1 in the equation P is equal to 2d1 L1 tau, when P is 57,805.3 Newton, D1 is 58 mm, and tau is 35 megapascal. Then L1 is. Again, when we substituting the values, so we are getting the value of L1 is 15 mm. So here in the options, the option A is 15 mm, B is 19 mm, C is 23 mm, and D is 21 mm. So the value of L1 is 15 mm, which is in the option A. Sixth one, diameter of socket collar capital D in the equation capital P is equal to capital D minus T1 into T into sigma C, when P is 57,805.3 Newton, D1 is 58 mm, T is 14.5 mm, and sigma C is 17 mm. Then D is, here the options are A is 74 mm, B is 115 mm, C is 54 mm, and D is 45 mm. After substituting the values, then we can calculate the value of D as 115 mm. That is, it is in the option B. So B is the correct answer. Seventh one. Thickness of socket collar L in the equation P is equal to 2 in bracket capital D minus D1 into L into tau, when capital P is 57,805.3 Newton, D is 115 mm, D1 is 58 mm, and tau is 35 megapascal. Then the value of L. The options are 8 mm, B 10 mm, C 15 mm, and D is the 14 mm. Here we are getting the value small l is 15 mm. So here the option is C. C is the correct answer. Eighth one. Width of quarter small b in capital P is equal to 2b t into tau. Again, when P is 57,805.3 Newton, T is 14.5 mm, and tau is 55 megapascal. Then the value of B is, the options are A is 69 mm, B is 79 mm, C is 89 mm, and D is the 57 mm. So here B means width of the quarter. So the value of B comes 57 mm. So here the option is D. It is 57 mm. So next is the references. So these are the reference books and a design data handbook written by K. Mahadevan and K. Balveer Reddy, which is prescribed by our board for references. So I have referred these books for preparing this session. So now, dear students, I am concluding this session, and I am thankful to our LMS team, our chairman sir, LMS coordinator, moderator, and subject expert for giving me opportunity for conducting or presenting this session. If you have any queries or doubts, please mail me, and my mail ID is tsitVnaik11@gmail.com. Thank you. Thank you very much.